I guess now it's a start. It's getting recorded.
Yes, yes. Yeah.
Okay. So hello to the only students that I have now.
Hello.
So it's last year also teaching C++. In the first lesson I had, I think, 15 or between 15 and 20 students. But in the next lessons, I only had one student. And because of him, I was teaching all the lessons. So it's not a problem to me. I will teach all the things, even if I only have one student. I think it's useful for everybody, but I understand that some people...
Yes, I think it's useful, but then I think for others, the main courses are getting really difficult, so maybe they want to concentrate on it. I'm not quite sure. Maybe that's the reason. Otherwise, the classes are interesting. Thank you for doing this. Yeah.
You're welcome. You're welcome. Yeah. Okay. So today we will talk about the solutions for the exercises. Unfortunately, I didn't receive any homework from you guys, but we will check the solutions for the exercises now. You can check. I suggest you first do it yourself and then check with the solution that I will provide in this lesson. And I will talk more on slicing and item assignments. Then I will talk about hashing and hashable objects. We referred to hashable objects in the last lessons that we had, but we didn't discuss about them enough. So today I will talk about them as well. Then I will introduce set and frozen sets to you, and also I will talk about control flows. Today we can only cover if, else, and loops. We have other control flows like functions and the rest that we will discuss about them in the next lessons. Then we will talk about iterables and unpacking and enumerating, which is really unique to Python, and the good aspects of Python is these things. And the last thing that we may have enough time to cover today is comprehension. If not, we will discuss about that in the next lesson. I asked you to do 4 different exercises, and today we will solve them one by one. The first thing that I asked you to do was to create a tuple which includes 3 items, a list of integer object, a float object, and a str object. So this is the tuple that I created. It includes a list, a floating point, and also a str. So this is a tuple. We said that a tuple can have is a collection of any data type. So it's not necessary to have all the elements of the same type. Here you can see it's a list, it's float, and it's an str. And then I ask you to try to update the elements of the list, check what happens to the tuple, and list objects by checking their IDs before and after the update. I ask this to make sure that you will understand how to use ID function and how the objects are working. We said that in the previous lesson that tuples are immutable objects, so we can't change them. We can do item assignments for them. But how about the time that we have an immutable object inside a mutable object? So here we have list, which is an immutable object, inside tuple, which is an immutable object. The list is mutable, tuple is immutable. Okay, I created this one. I print this tuple here. Then I'm printing the ID of the tuple object here and the ID of the first element, which is a list. So the IDs are different from each other because it's a different object. But I cannot do, for example, here, I cannot do this assignment for this tuple because tuple doesn't support item assignment because it's an immutable object. We said that mutable objects can be changed, we can change them, but immutable objects, we can't change them. So we can't do item assignment here. Also, I cannot concatenate another list to this list using this way, because again, for this one, I'm going to assign to do the assignments for one of the items of the tuple. So through this one, I can't. But this one is a list, and we said that list also provides some methods. Append is a method of the list. Okay, so through this method, I can append an item to this list. Now, if I print A, I can see that this item is added to this list. So I change the immutable object when I have a mutable object inside this one, but not through the assignment, through the methods of that immutable object, which is a list. Now okay, we said that if we assign another tuple to this tuple, another tuple will be created because we cannot change the tuples, but here we change that. So let's see what will happen to this object. Okay, I'm showing the ID of A and ID of the first element. As you can see here, the ID of the tuple didn't change, and the ID of the list also didn't change. So the tuple didn't notice actually that we changed that. It's another object. I'm saying that like this, but it's noticed that we changed that, but the ID didn't change. The object didn't change. So did you get this part? I can hear the voice, but I cannot hear you. Okay, let's see here what's happening. I think you are muted, but okay, you are muted now. Okay. Did you get this part? Can you tell me if you get that?
Yes. I did try this at home, and I think I tried it the other way. Can I post my answer in the chat box?
Yes,
could you please check and let me know if it's right or if there is something I need to change?
Okay. So this is a tuple. Okay, the tuple is created correctly, and you are changing. Yeah, you are showing that. You set that, and this is also correct. But you need to now to check the ID of the tuple and ID of the list. I think they didn't change, but just to get familiar with IDs, I suggest you to also check that, like what I did here.
Okay, so using the append
like
option. Okay. Yeah, thank you.
You're welcome. With this exercise, I wanted to tell you that you cannot change the items of tuples by the assignment, but you can change them through their own ways. For example, you here used the assignments of the list, but here I use the methods of the list. You didn't use directly the assignments of the tuple. By this, you use the assignments of the list.
Okay, okay, I understand.
Okay. And I also tried this for the strings. Strings are, again, they support item assignments, but sorry, they don't support that, but they also provide some methods. Let's see if I can change them or not. I said that this one is impossible. I cannot change the letter in this index. It's impossible, but I can I can use upper, for example, here. But upper doesn't change the string itself. It doesn't work in place. It's change the object and return that. So it doesn't change the object itself. It's like that. It will create another object, copy the data of the current object to the created to the new object, and then we'll change that one. So how can I prove what I'm saying? Is that, okay, I do this one, it returns an object, and the reference of that object will be inside the B. I'm printing B here. B is nasty, but when I print A, sorry, yes, I think I didn't follow that. Okay, A is this one, the ID of that. The ID of A2 is here, and then B is here, and A, I think okay, I did a mistake here, I guess. Where A is defined? Yes, I guess I did a mistake. No, it's not a problem, sorry. I'm changing this one, it's not another variable. And now I want to try to change this one. So when I refer to A2 to make it upper cases, I can't do that. It will just create another object and it will return it, and I will keep the reference to that object in the variable B. And when I do that, it will show this to me. But then when I print A, you can see that this A2 didn't get changed. So it's still as it was because it's an immutable object. And when I show the ID, so the ID also didn't change because we didn't change anything. And now I'm printing the ID of the A and the tuple, and now I'm trying to add another item to this tuple. I can do that. I can change this object like this, but in fact, I'm not changing the object. I'm just, again, creating another object in other location of the memory and copy this one and this one in the new object. So A is now referring to the new object, which is here, and it contains these elements and this one. I hope you get these things. If you do it yourself, you will understand it better, because when you say it in theory, you will you cannot memorize that. But if you do it yourself, you will understand it much better. So it's better when you just start to learn Python to use assignments, to use ID and type and the other functions to know, to understand what is happening in the background. And the other example was easier than this one. I said that given the following list, display the odd members in the reverse order. And I asked you not to use loops. So the list was this one, and now I create this list, I wanted to show the whole odd members. So in the last lessons, we discussed about a slicing, and to do a slicing, we did something like this. It has three different parts: a start, end, and a step. Since I want to traverse the whole list, so I don't need to define the start and the end, because I want to traverse the whole list. But I want to reverse to only display odd members. So the step should be 2, because you see that it's a natural list, so it includes odd and even members. And it should be in the reverse order, so it should be negative, such that I can traverse the list from this side to this. So then it will show me 9, step 2, 7, step 2, 5, and till the end. So this is how you can work with slicing. And the other exercise was this one. And actually, I just saw that you are familiar with that. In your first exercise, you use this way of indexing. But again, I will explain this. Maybe some other people wants to listen to this video and they don't know how to do that. To access the value of 13 in this tuple, how we should do to access to this member. So I created this tuple here just by this syntax, by this command, and now I can first access to this list. This list has the index 1, 0, 1, 2. Okay. So first, by this, I have access to this list. Now I want to access to an item of this list. So this list is also supporting indexing. Okay, if it was, for example, a set, I could not have access to that. We will talk about sets in the next slides. But just to let you know that if it was a set here, you couldn't have access by indexing, because set doesn't provide indexing. But here for the list also provides indexing, like tuple. So then I can have access to that using the indexing 0, 1, so 1 should be here. This is a list, this is an item of the list, and when I print that, it's an integer. I can do also such a thing for string and also for tuple, because they are sequential sequence data type, that all the sequence data types support indexing. And the last exercise was to store every element of the following tuple in 3 different variables. Actually, this is something that I didn't teach you in the last lesson, but I gave you this exercise to let you know that we cannot cover all the aspects of a language in a course, in a given course. I will teach you this part later on in this course, but sometimes there are some things, even when when new compiler are getting released, you don't know the new function, or when you are getting familiar with, you want to use a new library that you don't have any experience with that, you don't know many things inside them. So for them, you should be able as a programmer to search yourself, to Google what you need and find the best solution for that. So with this one, I wanted you to do something that you don't know how to do. But I will postpone explaining this exercise to when I will when I teach this topic. This week I was thinking that I was checking what I taught in the last lesson, and I noticed that I missed some things. I didn't. Some information are missing in the first lesson, so is missing in the first lesson. So with this slide, I want to just cover those information. That information, sorry. And by this, I give you those things by using different examples. So here, this is one example. I'm creating a list, and I'm creating another list using a slicing here. And as you can see, by type function, I'm getting the type of this results, and you can see it's list, even if the content, the members of the list is only even if this list only includes one element. So, but by indexing, this is not a slicing, this is indexing. So I wanted to let you know indexing is different from a slicing. But by this one, I'm accessing to this element, you see 1, and the type is int. So a slicing always gives us a list, no matter how many elements it includes. But item as indexing only gives us the elements, not a list. So this one is on 0 till 1, and 1 is not included. It's a list that includes 1. The other thing that you should know is explaining here with this example. I told you last lesson that if we create a list and if we assign that to another variable, both variables will refer to the same object. If we change any of them, the change will be shown by both variables, because both are referring to the same object. But sometimes you don't want to do this. You want to have a new list from the existing list. So in this case, and you don't want to, so you want to have two different lists, have the same value, but using, one of them will be defined using the other list. So if I do something like this, C, and use a slicing, then it will create another list for me because it's a slicing. And since I didn't define start and the end of the slicing, it means that it will give me a list of the whole items from 0 till the end. And then C will refer to that object. Also, I can do this using the constructor of the list, using the function that we have, which named list. And inside the list, we put an iterable, which is A, and A is the list. And D is now referring to this object. If we print all of them, now you can see that all of them has the same elements. I changed the first elements of A and by 10, and now I print all of them. You can see that A and B are the first elements of A and B has been changed by 10, has been replaced by 10, but C and D still have this one. You can see it here. Why? Because C and D are different objects. We created another list by this syntax. So if you are familiar, for example, with OpenCV, there we have OpenCV is also reference based. So if you want to assign a match to another match in OpenCV, you have to use a command which is called clone. So these are similar to that command. Another thing that you should know is this one. We said that we can use slicing to create another list from an existing list. But we can also update a list like using, and we cannot say it's slicing, but it's similar to that. For example, here I have a list and I want to change these two, replace these two elements with other elements. We know how to do item assignment just for one item. Now we are doing item assignment for two elements. So for doing that, 0, 1, 2, 3 until the end. So now if I print this one, print L, they are replaced by this. How about tuples? I just said that. For tuples, tuples doesn't support item assignment. And as you can see, the errors in Python are quite clear. So it says that it's not possible because tuple doesn't support item assignment. So before going to hashing and hashable object, can you tell me, did you get all the things that I said till now? I hope they are not confusing to you. Okay, I can understand they might be confusing, but the more you exercise, the more you learn. So these are, you will master them only if you do many exercises. Okay, let's go to the other topic. In the last lesson, I was talking about, when I was talking about dictionaries, I said that the key in the dictionaries, the values in the dictionaries can be of any data type, but the key should be, hashable. So, but I didn't, at that time, I just said that the key it's better to go for immutable objects for the keys. But I didn't talk about hashables in more details. Now I want to give you more information about hashing and hashable objects, because they are also will be used also for sets and frozen sets, the data types that we didn't discuss about them yet, but we should explain them in the next slides. Hashing is a concept in computer science that usually will be taught in the course data structure, or in the course information storing and storage and retrieval. But today I will only define that and give you some view of what it is and what it is used for. We will not go to the details, but I will give you some information to understand what is hashing, what is hashable object, what are hashable objects. When you are programming in any language, you usually need to use search algorithms or sort algorithms. In every languages nowadays, there are some built-in or standard libraries to do the search for you. But you should understand what is happening in the background to understand for your data which method is useful. The simplest search algorithm is linear search. I don't know if you are familiar with that or not, but I guess you are. But in linear search, we have a list of items. It's a collection of items, and we have a key. We want to find the location of the key in that list. So to do so, we compare the key with every element of the our list, elements of our list, from the beginning till where the key is located. And in the worst case, the time complexity is big O(n). It means that we have to do the comparison n different times if the key is not in the list, because we have to compare the key with all the elements of the list. But this is not the best solution for us. The question is that how to improve our search algorithm. One can answer this question by the first sentence that you can see here. By taking advantage of information about where items are stored in the collection with respect to one another. For example, by knowing that a list was ordered, we can search in logarithmic time using a binary search. For example, we have a list of items that are sorted 1 to 10. With binary search, we divide the list every time in 2 halves. And then we compare our key with the middle item. Since we know that the item, the list is sorted, so if the key is the middle item, so in a constant time we found the key. If not, we will search. If it is, for example, lower than the middle item, we will just do the search in the first half. We repeat this algorithm multiple times to find our key, the location of our key. So this can be done in logarithmic time. But one can say that we can also improve our search algorithm by hashing. What does it mean? By building a data structure that can be searched in big O(1) time. So it means that it can be done, the search can be done in a constant time. Formally speaking, hashing is a concept in computer science which is used to create high-performance pseudo-random access data structure where large amounts of data is to be stored and accessed quickly. Okay, this is a hashing method. Here we have the keys, here we have the hashes, and here we have a hash function. This is a hash function that maps these names to integers from 0 till 15. And as you can see here, there is a collision between John and Sandra. Let's go to the next slide and see what are these terms. The term that you have in hashing is a hash table, for example. A hash table is a collection of items stored in such a way as to make it easy to find them later. This is a hash table. A slot is each position in this hash table. It can hold an item here, and it is named by an integer value starting at 0. This is the name of the slide, starting at 0. This table has m slots, and the name of the slots starts from 0 till 10. And what is hash function? It is the mapping between an item and a slot where that item belongs in the hash table. So the hash function will take any item in the collection and return an integer in the range of the slot's name between 0 till m-1 because it has m items. For example, the simple function that we can consider as a hashing function, as a hash function, is remainder. It receives an item and divides it by 11, which is the number of items that we have in this example. So, for example, for 77, the hash function maps 77 to 0 because the remainder to 11 is 0. Also for 26, for example, the item will be mapped to these slots. This one was to storing the objects to our hash tables. What about the time that we are searching for an item? So now we stored the items in our hash table. Now we want to search for an item. We use the hash function to compute the slot name for that item. Then we check the hash table to see if it is present. So for example, for 77, I use that hash function, which was remainder, and it will map it to 0. Then I will compare if it is present. I compare that key with this one. Yes, it is present. But if it was, for example, 78, then I first use the hash function. It will be mapped to here. Then I will compare with the item stored in this slot, which is none. So I see that 78 is not here. So if everything is where it should be, we have found a constant time search algorithm. So we only need to do the comparison for one slot and nothing more. So it can be done in big O1. It's not like linear search that we need to search to compare our key with every element of the table, our collection, our list. But it is not the case for all of the hash functions. Even here for the remainder, we may have collision. Let's see what is a perfect hash function. Given a collection of items, a hash function that maps each item into a unique slot is a perfect hash function. But the remainder is not like that. For an item 77 or 44 or 33, the hash function will map all of them to 0. This is where we say that a collision has been occurred. So our goal is to create a function that minimizes the number of collisions, and it is easy to compute and evenly distributes the item in the hash table. I think this is for the moment for this course. Till now, it's enough for you to know about hashing. If you go to this address, it will talk about what are the other possible hash functions and how we can to make our hash table more developed, to be able to avoid the collisions. For example, you will see this photo where they will use a linked list for every slot instead of having only one item. They will not be they will not give us the perfect constant time search algorithm, but they will be better. So if you want to know more about them, you can go to either to this address or go to the books usually titled with information storage and retrieval. There you can find more information. Technically speaking, now, what is a hashable object that we have in Python? An hashable object, it has a hash value which never changes during its lifetime. Its hash value, it's like what's the hash function that we just said returns. So it means that, technically, it means that it needs a hash method. So an hashable object, a hashable object includes the hash method. Also, it can be compared to other objects. You just saw that for this, let me show you. For this one, we said that we need a hash value. With this one, we are saying that we need to compare to check if it is present. So we need the hashable object should be comparable. It means that it should have EQ method. Where it is useful? Where is it useful? As it is usable as a dictionary key and as a set member. These data structure use the hash value internally. We don't need to know about what is happening in the background with this set and dictionary. I mean, when they are working with hashable objects, but we should know that for them we have to use hashable objects, and hashable objects needs a hash method and EQ implemented. And okay, which data types now are hashable? We can say that most of Python's immutable built-in objects are hashable, but immutable containers such as tuples and frozensets are only hashable if their elements are hashable. For example, we just saw that we can have a tuple that includes a list, but then it is an immutable object, but it is not a hashable because it includes an unhashable object. Mutable containers are not hashable. List dictionaries, we cannot use them as a dictionary key or a set member. Let's see this example. This is an integer object. And now I'm showing you here the ID of this object, this integer object. And here you can see the hash value is 100. So the ID is different from hash value. Sorry. And here I'm creating another thing. It's not, yes, it's creating a string. The ID of a string, this string is this one, and using this method, I'm showing you the hash value. This is a tuple. We said that this container is also hashable if it doesn't include a mutable object. So this one has a hash value. Now I'm also adding I'm creating a tuple like this and showing the ID of the tuple and the hash value of that here. But this is a tuple that includes a list. The ID and the hash value was supposed to be printed here, but it gives me type error on hashable type list. when it tries to run this one, it says to you that list, which is inside this tuple, is unhashable. So it means that this tuple is also unhashable. Before going to set and frozen set, I want to ask you if you get hashing and hashables. I think this is that. Did you get hashing and hashable objects?
Yes.
Okay. If there is any question, don't hesitate to ask me. It's okay. But I can see the text. I mean, they grouped the chat room. So if you have any question, you should turn on your voice. Okay, in the last lessons, we talked about booleans, numbers, text sequence data types, sequence types like this one, and dictionaries. Now we are going to talk about set and frozen sets. We also have some other data types, as you can see here. I prefer not to discuss about this one because they are not commonly used in programming. They are mostly used for working with files and working with terminal. So if we find time in this course, we will discuss later, but not now. And then we will go to the other topics that we have here. But for now, we will talk about set and frozen set. Sets are mutable and frozen sets are immutable. They are very similar to each other, and their main difference is this one, that one of them is mutable and the other one is immutable. A set is an unordered and unindexed collection of hashable objects. It's unordered. What does it mean? It means that, for example, you will write a piece of code and there you will create a set, and you have 3 lines of code, and in every line you will add a member to this set. You may expect that the items in your set are ordered. For example, if you in the first line, if you add 1, and in the second line, if you add 2, you may expect that to see in your set when you are printing your set to see 1 and then 2. But this is not the case because set is not ordered. So it means that in every run of your program, if you print your set, you may see different order for the same piece of code, even if you are you made your code hard-coded. And it is unindexed collection of hashable objects. You just saw in your exercises that we can use indexing to have access to sequence data types like a string, like tuple, a list, range. But this is not the case with sets and also for dictionaries. For dictionaries, we said that to have access to their members, we have to use the keys. Dictionaries was a collection of key and value items. Here for this, with the sets, it's also like dictionary. Here, it's even worse than that, because when here we don't have even the keys. So we can't have access to the items like that. But how can we have access to the items of the sets? We will see that in the next slides. But what is the common uses of the sets and a frozen set? Is for membership testing, removing duplicates from a sequence, computing mathematical operations such as intersection, union, difference, and symmetric differences. As you're probably familiar with sets in maths, they don't have duplicates. So the members of sets, for example, we have set of natural digits. We have the set of even digits. we have the set of odd integers. So for integer set, you cannot say that 1, 1, 2, 2. You don't have duplicates. You have 1 and then you have 2, you have 3. So the definition of sets is like that. They don't include duplicates members. Set can be defined like this. It receives an iterable, and it can be defined with a set constructor. Non-empty sets can be created, non-empty, not empty sets, can be created by placing a comma separated list of elements within braces. If you remember, we use braces also for dictionaries. So that's why we are saying that if it is non-empty sets, we can use this one. But I recommend you to use this term before these braces for more readability, for more clarity. Otherwise, if you want to only create an empty set, you cannot use this one. If you use this one, it will create, without any member, it will create a dictionary, an empty dictionary for you. Sets are mutable. The content can be changed using methods like add and remove. But there is not any hash value. It cannot be used as a dictionary key or as an element of another set. So sets, this is the difference between set and frozen set. We said that the main difference is that set is mutable, frozen set is immutable. We said that sets and frozen sets include hashable objects. Okay, so they can't include mutable objects. So they cannot include a string. Sorry, a list. They can include a string. A string is immutable. But set themselves are mutable and they are not hashable. So we cannot use them for a dictionary key or a member of sets. So we cannot have sets of sets, because set includes hashable object, but set itself is not a hashable object. Again, I think it might be confusing, but if you practice more, you will master them. And frozen sets, they will be defined using this syntax. It's immutable and it's hashable. Did I receive any message? Is waiting in the lobby. Admit. Hello, Gyu. Can you hear us, Gyu?
Hi, yes.
Okay. And so we were discussing about frozen set, and we said that they are immutable and hashable. Its content cannot be altered after it is created, unlike sets. It can therefore be used as a dictionary key or as an element of another set. This is the main difference between sets and frozen set. I mean, the main difference is that one of them is mutable, the other one is immutable. And one of them is hashable, the other one is unhashable. So these will lead to some differences. We said that sets and frozen sets are unindexed. What does it mean? You cannot access item in a set by referring to an index or a key But you can loop through the set's items using a for loop, or ask if a specified value is present in a set by using the in keyword. Let's see here. This is a set that I'm creating. If I use this, I will get a type error, which says that set object does not support indexing. You see, again, the error is very clear, so it gives what you need to know, gives you what you need to know. And here I'm creating a dictionary. Actually, this dictionary is not a good choice for this data. So, but I'm giving this just for an example. You should know that when the key of your dictionary is just an integer, it's better to use, and it's like indexing, it's better to use a list, because list itself support indexing, and it doesn't need to store the indexes in the memory, because it support the indexing. But here for dictionary, if you define something like this, by this one you are storing those keys in the memory just to have access to the index of the values. But just give you an example of what is happening to show the difference between set and dict, I give you this example. So I'm creating a dictionary whose keys are some integers and whose values are some strings. So by B1, I can see this value. So I can have access to this dictionary through its key, to access to the values of this dictionary using the keys. But when I use B0, it gives me an error. But the error is different from the error that we got for set. It says that it's key error because 0 is not existing in this dictionary. So it's different from that one. So for dictionary, we have it, even although it doesn't support indexing, but it supports key. So it supports keys, so we can have access to the values through the keys in dictionary. But for set, we only have to use for loop, or we can use in keyboard. I will talk about this one when I will discuss about for loops later. Sets and frozen set, like other data types, support some operations, like some methods, some functions, like len of the set, x is in S or not in, if a set is subset of another one, union is superset, difference, symmetric difference, copy. For set we have update, but this frozen set doesn't support update. You should keep this in your mind, that everything that will change frozen set are not supported, even if the sets are supporting them. Pop, clear, remove. So in the next slide, I'm giving you some examples of this operation. Let's check. Let's read this example one by one, one line by one, each line, one after another, to understand more this operation. I'm creating here a set. It includes, we said that for non-empty sets, we don't need to write set here, but I do recommend you to write. So here it includes 3 different elements. The type of my set is set. Now, this one, I said, if you don't write set or dictionary here, this will give you a dictionary, an empty dictionary. You see the type is dict. So if you want to define an empty set, you have to write set here. Then when I check the type, it gives me it's a set. Now I'm creating another set, and this example now is very similar to the examples that we have for list. But some of the operations, that we did for list are not supported for sets here. Let's go through them and see what's the difference. I'm creating a set like this, and I'm creating a tiny set here. You see, I have two elements which are duplicates, which are similar, which are the same. But let's print my set here. When I print my set here, I will only see one element of two because set does not support duplicate. The length of my set is 5. This one is impossible. We said that. Indexing is not possible for sets. Also, we cannot have this operation or this operation for sets, which we had it for lists. But in contrast, we have union operation here. We union tiny sets here, and we print them. This is that. When I print that, it's the same because both of them has the same elements. It doesn't support duplicates, so it gives me the same set. Let's union my set with tiny set. They have the same value, John, but they have some other different values that are not in some of them, in one of them. When I do this, my set with tiny set, John is only one in this set, and we also have the other elements here. We can also use in to check if this element exists in this set or not. John is in set, true. John is not in my set, false. I will show you here the ID of print. I will print the ID of my set, and you can see this is the ID of my set, and this is the my set. We said that we can update sets because they are mutable objects. I will add 5 to that, and then I will show the ID of my set and the set. This is the ID of that. You see the ID didn't get changed because it's a mutable object. And it also includes the new item. Now we said now we want to update this set with multiple updates and multiple items. Update gets an iterable object. Here the iterable object is a list with elements of 10 and 20, and I will show that here. So this is the ID, and this is that. This is 10 and 20. As you can see here, we said that the elements of the set are unordered. So the 10 and 20 was the last items that I added to this set, but you can see 10 is here and 20 is here. And if I run this piece of code again, these results will change. It might be here, 10 might be here, John might be here. So in every run of your program, you may see different results, different order, not different, totally different. The order will change. And here I'm trying to update this one with list, with set and an item. It is not possible. Why? Because we said that sets includes only hashable objects. So, and we said that set is not a hashable, so we cannot add a set to a set because set is not hashable. But we can add some other hashable like lists, like strings, or sorry, not lists. Lists also are not hashable, like the elements of the list, like a string, like tuples and the others, the other hashable object. It doesn't even also support deleting, but it supports remove and pop. So if I run this one and show the by remove 2, I'm saying that the item whose value is 2 should be removed. And as you can see, 2 is removed here. And since the sets are mutable, the ID didn't get changed. But with pop that you are already familiar with in the lesson that we have with list, I'm popping one element from the front and put it in name in this the reference to that item in this variable, and I show the ID of the set and the set here, and you can see that still we are working with the same object. Sorry. The other example that we have here, giving us some other pieces of information, is this one. Here I'm creating a set. With this one, I'm showing the ID of that. With this operation, with this command, I'm union this set with this set, and this ID shows us we still are working with the same object, even if the data has been changed. We can see 20 here, 30 here, and this one here. Now with this one, I'm creating, sorry, 3, yes. Sets and 20, sorry. Okay. I'm adding my set with this set and put it to into my set. And as you can see, the ID of that has been changed. A new object is created here. Why? Because we said that to define a new variable, we don't need to, like C++, we say int the name of the variable equals to a value, semicolon. We said that only the assignments like this will create an object for us, even if they are mutable objects. So this one is like updating the existing object, but this one is asking the interpreter to create another object. So as you can see, another object is created and the data is here. And my set is now referring to another object. So it's similar, this line is similar to this one with another variable. And as you can see, it also has another address of memory. You can see here, this address is similar to this address. This is because of the interpreter that I'm using. Since this interpreter thinks that, okay, my set is now referring to this. No one is referring to this object with this value. So the garbage collector will release this item, this part of memory, When I need to create this object, it will use that part of memory to create, to save this object. But with some other, you may see different address here. I mean, you should not confuse this one with this one. You should not think that this object is the same object as here. This is a new object. This object is thrown away, has been thrown away by the garbage collector, because after this statement, no one is referring to this object. But this way of garbage collection might not be the case in all the interpreters. So for example, if you use other interpreters, other online interpreters, you may see different address here. Some interpreter may reserve this one for you for later, and with this statement, they may not use this location of memory. They may use some other, because they are different. So the similarity between this address and this address doesn't mean that they are the same object. It means that the garbage collector has deleted this object and replaced it with a new object. Use it for a new object. And I'm doing the same example for the list here. So for the list, I am creating a list like this here. The ID has been shown here. I'm concatenated with a new list here. It still have the same address, and it's also included. I mean, the new items included. And now I'm using this statement, which leads to creating another object, and I'm adding 20 and 30 with that. You see here. You see here when I try to add 20 and 30, I have duplicates, but this is not the case with sets. If I add like this, if I add this one multiple times, we will only have 2 and 3 one time in our resulting set. So, but again, we can see that a new object is created because this is similar to variable definition, object creation. And here, when I add this one with this and put it in a new variable, you see it's created a new object here. It depends on my interpreter. It could even also use my list, because here there is no variable that is referring to this object. You can see my list is now referring to this one. No one is referring to this. It depends on the garbage collector. We don't think about this part because this is the responsibility of our garbage collector to delete this one. It will do it during the run of our program whenever it thinks correct. They have their own algorithm. Before going to, let me see. Okay, before going to frozen sets example, can you tell me if you get all these things?
Yes, I did.
Okay, if you have any question, you can ask. Okay. I'm doing the same examples with frozen sets, the same example that we saw in, in these slides for sets. Now we are doing that for frozen sets. So to create an empty frozen set, we should use this syntax. And if we show the type of that, you will see this is a frozen set. I'm creating 2 frozen sets here, print the frozen set here, and the length of the frozen set here. And this one is impossible because indexing is not supported, like in sets. Also, these two are not supported. We can do union here, and you can see the union also. Sorry, this is the union. Since it is, this one is union with itself, so the element, it doesn't change the elements of the tiny set, but we can union these two together, and this is also similar to sets. Also, we can check if an item exists in a frozen set. Again, this one is similar to sets. And I'm showing the ID of frozen set here and the frozen set. You can see here. It is impossible to use add or remove and the rest because frozen sets are immutable. And in this one is not possible. It's just duplicate. I should comment this line as well. And okay, I think I commented one line. Pop, yes, I think this line was commented. Where is pop? Yeah, the error that you can see here might not be similar. After running the program, I commented this line, but if you also consider that this is not commented, this is a comment, then you will see this error. So since I commented, you cannot see. So all these commands are not possible to be with frozen sets, are not possible with frozen sets. And the difference between frozen set and sets, you can see here, this is a frozen set, which includes a frozen set. It has an element of like that. But here also I'm a set, which includes a frozen set. If I print these two, you can see this is a set and this is a frozen set. All of them, both of them includes a frozen. And here I'm creating a frozen set, which includes a set. This is impossible, as I said multiple times till now, because set is not hashable. And you see here unhashable times set. Oh, this would not be also true because again, set is unhashable. And here I'm my dict unhashable set. Okay, I'm also giving an example to show you with the dictionary. I created a frozen set here and a set, which both of them includes frozen sets, but it's not important. One of them is frozen set and the other one is set. One of them is hashable and the other one is unhashable. Now a dictionary here whose keys should be hashable, so we can have a dictionary whose keys is frozen set like this one. If I show that, it's a dictionary like this. The first elements of this dictionary is this one, whose value is this and whose key is this one. And the second elements of the dictionary is this too. And when I try to create a dictionary with a set whose key is whose first element is and list, it's impossible because set is unhashable. We could not also put here list or the other unhashable items. So if you want to have a set of sets, you have to use set of frozen set or frozen set of frozen set. Or if you want to have a set as a key of dictionary, you have to use frozen sets. I just explained to you that some interpreters are working differently. They may work differently different from each other. This is the same piece of code, and I ran them on different interpreter, on different online interpreter. Sorry. And as you can see here, in this one, let me explain. This is a frozen set of frozen sets and a set of frozen set. And I'm showing the ID of frozen set here. This is the ID of frozen set and the ID of frozen set of frozen set. And you can see they are different from each other, as this was the case also with other containers. And I'm showing here the frozen set here. And I'm showing the ID of my sets and ID of this one. And as you can see, the ID of this one is different from this one, but both of them are using the same address. And as I said previously, this is because of the garbage collector. No one is referring to this object, so the garbage collector will throw this away and will replace it with this object when this object is created. But with this interpreter, as you can see here, the code is similar. This one, or I can say even here, this one has this address of memory, but this one has this address of memory. So it means that the garbage collector is not, I mean, the interpreter is not using the same location for this one. So when you see these two have the same address of memory, don't think that they are the same object, as they are not. This is only because no one is referring to that object, and the garbage collector has thrown this away and is using the same location of memory for two different objects. Okay, now we should talk about control flows, but before that, is there any question about frozen sets, anything? What does it mean, hash? Actually, you should listen to the, watch the video, because we discussed about hashable hashing. But in summary, I can say that a hashable hashing is used for improving our searching algorithms, and an hashable object includes a hash value and also equal function. So hashable objects has two methods. One is hash and the other is EQ. So these two methods helps the other algorithm, the search algorithm, to be more faster. So, but if you listen to the video, you will understand what is hashing and hashable. We discuss a lot about them. Is it okay, Kiyu? Okay. Okay. So now we are going to talk about control flows. I think this is the middle of the class now. Yes, it is the middle of class. I hope you are not tired, as I am. And I try to explain one thing multiple times because I think they are confusing. And but if you listen to the video multiple times, or if you practice by yourself all these examples, if you write them yourself, check the IDs, check the type, check the functions, you will understand them much better. You can memorize them. You may get them now, but you may forget them. So it's better to exercise to be able to master them. Like control flows, like any other languages, we have different control flows in Python. The one that we will discuss today is our if statements and loops. And if statements, if you are familiar with them, have here they have this syntax: if condition 1, a block of code that will be run if condition 1 is true, And elif, it's like else if in other languages, and it has another block of code that will be run if condition 2 is true and condition 1 is false. And else is, here we also have another block of code. It will be done if all condition check which are checked above are failed. So an example here is we have, for example, var equal 100. Actually, you may think that if you are familiar with other programming languages, you may think that this example is not really interesting because we could implement this one with switch case. But in fact, in Python, we don't have switch case. If you want to provide a switch case, either you can implement that by yourself. I mean, you can mimic a switch case by yourself, or you can use if else. So var, this is an integer variable, and here I'm saying that if it is 200, this piece of code should be run, but it is not, and it's not also 150. It's here 100. Since it's not these ones, this one will be run, and the value will be shown here. And after that, nothing will be ran, and the code after this if statement will be run, which is print goodbye. So it's very simple, and especially if you're familiar with if a statement in other languages, it's exactly like them, but with different syntax. Let's see what are the loops in Python. So loops are useful when you need to execute a block of code several number of times. It would be this. I found this one on the internet, so you can see that there is a block of code and a condition. If this condition is true, this block of code will run, and this will be repeated as long as this condition is true. And once this condition is false, then the interpreter will go outside, will exit this body of the loop. We have two different loops in Python, while and while else, in fact, and for else. This is really unique to Python. In other languages, to my knowledge, there is not there. We don't have such a syntax. We will discuss about else statements later on in the other slides. But here, while it is like a repeated if statement, the code is executed over and over again as long as the condition is true. So this is the example. This is the iterator of my loop. It is initialized by 0, and the loop will be will be executed as long as this condition is true. And the body will show us these messages from 0 till 8. So when it is 9, consider it is 8. The 8 is lesser than 9, so the count is 8. Here 8 will be plus by 1, will be added by 1, and then 9 is not lesser than 9, so then this body will not be executed. Another example here, var is equal to 1, and I'm saying that run this one as long as this condition is true, but this condition is always true. So this constructs an infinite loop for us. And the only way that we can terminate our program is using Control+C, Control plus C in our keyboard to be able to exit this run of code, this process. You can also, you don't need to use this equality operator. You can, if it can be a Boolean, or if it can be processed as a Boolean. So I can put here flag and print this one. But this is true. Again, this will create an infinite loop for us. What is an infinite loop? Sorry if I said before. What is the other loop? For actually, while are not much common in any languages, especially in Python. For is more common than while. For statement is like this. It also has else that I forgot to write it here, but this one is also has else. But the structure is like this: the iterating variable and the sequence. This sequence is an iterable object, and this one is an iterator. We will discuss later in the slides that what is an iterable object and iterator. But just to make you familiar from this slide, I'm saying that this is an iterator and this is an iterable. And here you see, we said that range is a data type, a sequence data type. So sequence data type is an iterable. It means that we can iterate over its elements. I'm saying by this one, I want to iterate over the numbers inside the range, and it will gives me this one. And after that, we print this message. It's from 0 till 9 because we said that in range, this one is not included. This is the maximum number, but it's not included. Like a slicing, the end is not part of the range. Here I'm creating a list, and I can also I have two ways to iterate over the items of this list. This is the way which is very similar to other languages, for example, in C++. But in Python, it's better not to do that. But just to show you how you can mimic that for loop that you have in C++ in Python. So I give you this example. So with range of length of this list, I'm creating a range of 0 till 3, and I have access to these elements, to the elements of the list through their indexes. And then I will show them here. Current fruit index is 0, banana, index is 2, apple, index is 3, mango, index 4 will not be included. We said that the last one is not included. Length of fruit types is 3, but the range of 3 is 0, 1, 2. So the better solution, not the best one, the better solution to iterate over the elements of a list in Python is just like this. This one is like for each, for example, or for auto : in C++. So with this one, since fruit type itself is an iterable, I can iterate over its elements. I don't need to create another iterable object to iterate over this list, because the list itself is an iterable object. So with this, again, I'm creating the same output as this one. What are the loop control statements? Break and continue, like other languages that we have them. So if you have them, if you are familiar with them in other languages, these are exactly the same as what they are in other languages. But if you are not, let me explain what are they. We said that we have a loop, that a body of the loop will be executed as long as the condition is true. But we have also break and continue. If inside the body of the loop there is a condition, and if that condition gets true, the break statement is run. Then the interpreter will exit the body of the loop. We will see later in the examples. It might be more clear. It might be clear. And for continue is like that. In the middle of your body of the body of your loop, if a condition is true, you will say to the interpreter, I don't want to continue this run of my my loop and go to the next run of my loop. Let's see with the examples. This is a string. A string, we said that it's a sequence data type, it's iterable. So I'm iterating over the letters of this string, and I say that if you meet H, then quit this loop. What does it mean? What will happen? P, Y, and T will be printed. When H will be met, then we break this loop. Nothing will be shown after that. How about here? We have, we can also do that with, okay, I wanted to, this is exactly the same, but I wanted to show you also with while. With while, we don't have in here, so we have to create an iterator. So I'm saying that iterate over the elements of the key using this iterator, and I said that while is not really common because this is much more readable and much cleaner than this one. So again, I say that if key of I is H, break this one. So it's similar. So both of the code are producing the same output with break, and but this one is much more cleaner, much cleaner. How about continue? Here, I'm saying that if you meet H, go to the next run of this loop. So H will be ignored. P, Y, T, O, N, H is ignored. Also here, but you see the difference between here and here. I put I plus 1 here in break because I didn't want to continue running this loop if it is H. But this one, I have to put this updating here as well. Otherwise, it will stuck in this one, and it thinks that it's all of the time it's on H because I is not getting updated. So you should be careful when you are using continue and you are using while. Because the updating of your iterator is your responsibility. You should update that, and if you don't do it before continue, then you will stuck here and you will have a loop an infinite loop, which doesn't do anything. The other statement that we have is pass. Some people put it as the loop control statement, but in fact it's can be used anywhere. It's not only for loops. The pass statement is a null operation. It does nothing. When it executes, nothing happens. The pass is also useful in places where your code will eventually go, but has not been written yet. For example, here, when I say that if it is age pass, it doesn't do anything. It shows me age. It's usually used as it is. It says it doesn't do anything. You cannot, for example, make this one comment with having if, because if needs a body. So pass is a block of code that doesn't do anything. So it's a null block of code. So if you want to just create a block, but you want to fill it later on, you can write pass for the moment and fill it later. It can be also used here with the same results. Okay, if you get, sorry, sorry, if you get loops, tell me if you have any question about loops. Then, if not, we can go to the else statement in the loops. Is it clear? Pass could be used as a delay. No, it doesn't do anything. For delay, you will ask the your processor to wait for you. You will ask the CPU to wait for you. But so, for example, you will delay running your program by 2 seconds. So the processor will stuck there and don't do anything. It doesn't do anything. But with pass, it just pass. It doesn't do anything and just pass. Actually, it should not take much time. It's just for like putting some comment for yourself that you should write something there. In C++, you could use braces to create a block, an empty block of code. But here we can use, for example, pass. You can consider that as an equivalence to that one. Is it clear? You're welcome. What is else in loops, which is unique to Python and we don't have it in other languages? At least to my knowledge, to the languages that I'm familiar with them. Here I'm creating, I can say else statements will be ran only if if the loop is completed or it will be passed. Otherwise, else will not be ran. But let's see what does in the examples how it works. Here I'm creating a for loop from which iterates over the numbers 0 till 9, and it will be completed. And since it is completed, it iterate over all of the elements of this range. The else statement will be run. How about this one? The condition is not true. We are saying that range of 10 till 0, but range of 10 till 0 is nothing, is empty. Okay, so it never enters to this body and it will pass this 4. So in this case, also the else statement will be run. So the else statements will be ran. Either the condition is not true, or it means that we passed this one, or it will be completed. When doesn't it get run? Here, I'm saying also for continue also it will be run because every elements of this range will be met. So again, for this one, completed or passed will be ran, but here for break, else statement will not be ran because I'm saying that if you meet 2, the index number 2, the element number 2, break this 4. So you enter this 4, but you didn't complete that. You didn't traverse all the elements. Then else will not be ran. So you may think that, okay, what's the usage of this else? What should we do with this one? Let's give you an example. You can do this example with other approaches. You can implement that in other ways. But just to show you how else can be useful, I'm giving you this example. Suppose we are working with terminal and we are asking the user to enter a sequence of numbers, and when the sequence is done, and enter a sequence of number, and at the end enter a flag to let me know that where is the end of your sequence. This can be much more complicated than what I'm talking about now, but I'm making a very simple example. So, and if the user didn't enter that flag, you want to let the user that there is an error. How can you do that with 4? So this is 0, 1, 2 that we assume that the user entered. We wanted him or her to enter underline also here at the end of this str, but he or she forgot to enter that. So now I'm iterating over this list and I'm showing every item of this list with these indexes. So I'm converting C to int and getting an item of this list with my list with this indexing method. And I'm saying that if you meet this flag, which is supposed to be met, break the loop, don't continue. But since the user didn't enter that, we don't break the loop. And we said that if it gets completed, or if we pass this one, for example, if my str was empty here, we pass this loop. In both cases, else will be run. So now we can tell the user we raise an error. We will discuss about exception in the next lesson. We raise an error and we let the user know that there is an error. You forgot to enter the flag. Okay? So this is the usage of that. We could, for example, have a Boolean number here, and if we met this one, save a Boolean to true, set the Boolean to true, and here write an if else statement and say that if that Boolean is true, raise this error. Okay, this was another solution for that, which is the case with other languages. But they provide this one to let you avoid those syntaxes in Python and to be able to have else with with the loops. Before going to iterables, is there any question? Did you get what is else in for loops? Okay. Okay, if there is any question about that, let me know. Let's go to iterable. Let me see how many slides are left. It would be great if we cover least comprehension. I guess we have to cover comparison in the next lesson. I don't. Let's see. I already talked about iterables when I was talking about loops, and so we encountered the term iterable and iterators in when we were talking about for loops. Sorry. Our encounter with for loops introduced the term iterable, an object that can be iterated over, such as in a for loop. So in an iterable, formally speaking, an iterable is any Python object capable of returning its member one at a time, permitting it to be iterated over in a for loop, such as lists, tuples, strings, dictionaries, and sets. So all of these things are iterable. For example, even if sets doesn't provide indexing, but they are iterable, we can have access to them, to the items of them, using for loops. It is also possible to have an iterable that generates each one of its member upon iteration, meaning that it doesn't ever store all of its members in memory at once. If you have any experiments with deep learning, usually we are working with databases. And we usually prepare a data generator. There it's when we call that data generator, it gives us access to its members. So every time it gives us a new sample. So there they are not lists or tuple string dictionaries. They are much bigger objects that they may include other data types, but there the iter and next methods is implemented. So it means that we can define a class, an object by ourselves, and we can also define iter and next object inside them to have to make them iterable. Then we can use for loop for our classes. Okay, and also we don't have to, it's not necessary for us to keep all this data in our memory, in our RAM. We can have them in our, for example, in our hard disk. And in every, the iter and next method will be called, we will upload them from our hard disk to our memory, and we can also release them. So in Python, we can say that an iterator is an object which implements the iterator protocol, which consists of the methods iter and next. I think I made a mistake here. Iter and next are useful to create an iterator, and they will use our iterable objects to load the information from them. The built-in functions that accept iterable as arguments are like this: list, tuple, dict, sum, sorted, max, min, and the other function that you see. As you remember, we were using, for example, we said that when the syntax of creating a set is set, parentheses, and an iterable. So it's not necessary to have a set inside that constructed as an input, as an argument, to be able to create a set. It can be a list. So it's when you see somewhere in the documentation that says that here you see the term iterable, it says that it can be any data type that is iterable, that we can go through its elements to use it for other application. For example, to create a list, to create a tuple, to create a dict, and the other things. Iter is used to get an iterator from an iterable. Any returns true and ends the iteration immediately if bool of the item was true for any item in the iterable. And all returns true only if bool of the item, this method, was true for all items in the iterable. So you need to work with any and all. You probably need it when we are working with lambda function and the rest. I will give you some exercise in the lessons about them, but not now. For loop actually creates an iterator object and executes the next method for each loop. For example, here we have an iterable object, which is a tuple. And with iter, I'm creating an iterator from this iterable object, and I'm saving here. If you remember, in C++, for example, we have vector, and we can create an iterator from that vector and we can traverse through the items of that vector through that iterator. This one is similar to that one. And using next operator, we can have access to the other elements of that. If you are familiar with linked list, you know that, for example, we had a pointer, and using that pointer, we could add the pointer, the address of the pointer by 1, and then we could have access to the next element. But here, it is similar to that because we said that everything in Python is an object, everything is reference. So it's similar to that, but the syntax is somewhat different. Now, instead of adding my IT by 1, we are using this method to have access to the other elements of this tuple. To create an object and class as an iterator, you have to implement these two methods for your object. So, iterable are very useful in Python, and Python provides some synthetic tricks for working with iterables. These are the things that make Python unique, make Python useful. Like MATLAB, that is very useful for working with matrices. Python is also like that. It's very useful for working with tables, with working with lists and everything. So the two things that we should learn about that is unpacking iterables and enumerating iterables. If you remember, the fourth exercise that I gave you was about unpacking. I told you I didn't teach these things to you, but I wanted you to find it by yourself because Googling is really important to learn. Actually, it's not just Googling. It's you could implement that one with for loops or other methods, but it's really important as a programmer to find the best solution just by searching. And so imagine we have, suppose we have this list, and I want to create 3 different variables with the elements of this list. I can do like this, like other languages, what we do in other languages, to have access to create X, Y, and Z with the elements of this object. But the nicer way of doing that is unpacking. You can just write my list here and X, Y, Z, and it will unpack the list for you here. This is really good because you don't need to think about the index of your my list. You only need to think about the list rationally and unpack them like this. We can also do it for a list of tuples, for example. And now I'm going through with this loop. I'm going through the elements of this iterable, which is a list, and I'm printing that. So every element is a tuple, and I'm seeing that here. But I can also use unpacking inside the loop. Name and grade. I'm saying that give me, when you are giving me every elements of the grade, unpack them for me and put them in name and grade. So name is now a string and grade is an integer, as you can see here. I'm explaining unpacking in more details with these examples. So first with lists. Imagine we have this list. In fact, suppose you don't need to imagine something. Suppose you have this list, and now you want to create 2 other lists from that. You can do that using a slicing and indexing. So the first elements of this one is going to be in first variable, and the rest is going to be in the rest variable. I think you know that they will not be inside this variable. Only the reference to them will be here. The address of them will be here. When we print this one, you see this. But we can do it in a nicer way with this one. So with the star, I'm saying that first here, the rest in this one. And if I show that, I can see this. Now, let's see, we want to have the first element in A, the last elements in C, and the elements in between in B. We can do it again with a slicing and indexing, and it will be like this. But we can do it with unpacking. A, C, star, and just the name of the list. You see, it's much nicer than having to think about the indexes. We don't need to think about the indexes here. We can also use this syntax for that, and it also gives us the same. If you remember, I told you in the first, not the first, in the earliest slides, I told you if you want to create another list from an existing list, you could use slicing, you could use the constructor of the list. I'm now giving you the third way of doing that. So with this syntax, I'm creating A. A is not sec, is not this one. In fact, it is a new variable which has same items as this list. But this one gives us a syntax error. So as you can see, A has these values. Let's do this one, the same things, not exactly, but similar, with range. I have a range. I said that if you want to print range of 5, it will only show you that range of 5. If you want to see the elements, you have to convert it to list. So if you just saw that that list accepts iterable as an input. Range is iterable, list is receiving an iterable and producing a list of that, and print is showing that here. So I can also do this with a range of 5 and A, B, C, and as you can see, it gives me this and this and this. I could also do this one with the slicing and indexing. Again, I can do this one here. It will give me a list of the elements of this range. You can see here. Let's do it for list of tuples. And I want to go through this one, go through the elements of this list and unpack every element like this. So I can use, again, this way of unpacking inside a loop. A would be 1, and the rest would be 2 and 3. And I'm showing B here, 2 and 3. For the other one, A would be 4, and the rest 5 and 6 and 7. Here for dicts. For dicts, I said that it doesn't support indexing. We can't have access to them through the indexes, but it has some methods like items which supports indexing. No, I'm not sure it supports indexing. No, it doesn't support. I tried that actually. It doesn't support. But its f-type items returns a data type of type dict items, which also doesn't support indexing. But with this one, I can work with this way of unpacking. If you don't write this one, it will only unpack the keys for you. But you don't want to only unpack the keys. You want also unpack the whole elements. So you want to have first Ashley 93 and the rest here in this one, like this. But if you want to unpack only the keys, you don't need to write items here. And I tried to do this one with indexing and slicing, and I noticed that dict items also doesn't support indexing. How about sets? Again, sets doesn't support indexing, but we can unpack them like this. So you can see that unpacking is cleaner. The clumsy index handling is not necessary anymore. And if the right-hand value is not a list, like dict and set, which doesn't or not exactly list, but anything that is not supporting indexing, but an iterable, it has to be converted to a list before being able to do a slicing. This is not a, I think I have to change this one a bit, because, for example, this is not the case for a string. For a string, it supports indexing, and we can do that. We don't need to convert it to a list. But for the other ones that doesn't support indexing, we have to convert them to a list to be able to use a slicing. And you can see that if I don't convert this one to a list, I can't use a slicing. The only way that I can do is this one. And it is better not to convert them, because when you convert them, you will create another object and you will get memory for them. It's not memory efficient, it's not time efficient. So I just said that, it's just a repeating what thing, but just to have one slide to show all the ways that you can create a new list object using all the elements of an existing list. I put this example here. So we said that if A is this one, you can either use this way or this way or this one to have a new list from the elements of this one. And as you can see, all of them has different IDs. If you don't do that, if you just write, for example, E equals to A, a new list will not be created. In fact, both of them will refer to the same object. We discussed about this in the earlier slides. I have here one example, which is the example, the exercise that you had, I guess. Yes, am I right? This is the exercise. Let's just store every element of the following tuple into. Yes, I think this is the exercise. Can you tell me now how we can do this? Let's look at this first in this right side. Can you give me the answer to this one? How can we unpack this? Yes, but I'm talking about unpacking the thing that we just learned. How can we unpack to have 3 different variables? Each of the variables, we have each elements of the tuple. I can copy that one here, then you can be faster with writing. Exactly. Yes, thank you. So for this one, I'm creating a tuple and I can do something like this. I can also do this one for, I can also do this one with, this is a tuple. I can do this one for lists, and also it will gives me, it will unpack that, because both of them are iterable. I can also do this one for a string, because a string is also an iterable, and I can unpack them. How about this one? For this one, it will give me only the keys of that, because I used my dict. In the previous example, we saw that if we want to unpack a dictionary element, the dictionary elements, we have to use items method. Otherwise, it will only unpack the keys. As you can see here, it unpacks only the keys. And here, this one is impossible because it says that it has too many values to unpack. I'm asking that to put the elements of this one in A and B, and if this one is impossible. I could put here a star, then it will put A only one of them, and B would be both of them. So this is the answer to your, actually this is only the answer to your exercise. These are just some other examples which were similar to this. I wrote them here to have them to know more. I really expect you to also to do something like this. When you do an exercise, think with yourself, okay, what will happen if I do this one for other data types? What will happen if I do it like that? What will happen to the memory? So you should think about all these things. This makes you really a programmer. And what time is it? Let me see. Enumerating and exercise. Yes, let's finish enumerating and then we can finish the course, finish the lesson today. So the other thing that is provided by Iterables are enumerating and the Iterables. So the built-in enumerate function allows us to iterate over an iterable while keeping track of the iteration count. So till now we saw that we can iterate over any iterable, even if they are not supporting indexing, because we have for in, and in that lets us to iterate over their items. But sometimes we want to have also the iteration counts, because for in with this one we don't have any iteration counts. So the enumerate function accepts an iterable as an input and returns a new iterable that produces a tuple of the iteration count and the corresponding item from the original iterable. But okay, how it is possible? With this one, just simple traversing. I have a string, and for entry in this one, I'm printing all of them, A, B, C, D. I don't have any iteration count here. I'm just having access to the elements of the string. With this one, I'm traversing using enumerating, okay? An entry gives me a tuple of the iteration counts and the elements. You see here, iteration counts and the elements. When I print that entry is like that. Now I'm traversing using enumerating and unpacking together. So it enumerates all of them, and now with this one I'm unpacking the tuples in every iteration. So now these tuples will be unpacked to ITR and entry, and I'm printing them like this. This is really useful. The example that you can see here, for example, here I have a list and I enumerate over this list, and I unpack them like here, and it gives me 0 apartment, 1 house. I can also do the same for tuple. I'm showing you here, we can show the message with concatenation like this one, 0 apartment. So again, it's similar to that one, but this one is tuple. I can do that for a string and show the message here, as you can see. I can do it also for sets. We said that set doesn't support indexing, but we can have access to its elements through a for. And to have the order, we can use enumerate. But we said that set is not order. So in every run of your program, you will see different thing here. For example, you see now here 0 house, 1 apartment, and 2 studio. Okay, so another time that I will run this program, I may see that 0 apartment, 1 studio, 2 house. So every time it changes because set doesn't support. I mean, sets are not in order, but still you have something like this. And I mean, it is still possible to use enumerate for sets, even if it may not make sense. We can also use enumerate for dictionaries. Again, dictionaries are unordered, and in every run you may see different things. With these 2 examples, I wanted also to show you that, and also here to show you that you can format your text, your string, like this. Here I concatenated these 2 strings, these 3 strings together. Item was a string, this one is a string, and I'm converting I to a string because it's an integer. But here I'm saying that I have 2 string here. This is the whole string that I want to show. Put here the string, put here also a string, and I'm putting them here, and the combination would be like this. For this one, it would be like this, sorry. For this one, I'm saying that it's a string and it's a digit, it's integer. And also you see this one. So I think we cannot cover how you can manipulate your string, how can you generate them. We don't have enough time for that. If we find time, we will talk, but with this example, I wanted to also let you get familiar with these formatting, text formatting, but you can learn by yourself. They are not at all difficult at all. So one exercise that is left, okay, which I don't want to again give you this answer to this exercise. It says that given the following list, we want to record all the position in a list where the value noun is stored. Okay, so it would be really great if you do this exercise and send the answer to my email. This one is really simple, and it's only one exercise. And I'm giving this to you to at least you will know that you learned something after doing this exercise. And if you didn't understand something by doing this exercise, you will notice that you didn't get something. And in the next lesson, you can come to me and ask me, I didn't get this part, I couldn't do this exercise. But if you don't do the exercise and you just listen to me, the chance to know that you have some problem is really low. So this is the whole thing that I wanted to teach today. If you have any question, you can ask. Otherwise, we can stop the lesson. I hope it's not much confusing, but you need to practice, really. You need to practice. Is there any question? No? No one? No question? No? Okay. Okay. Okay, I will send this files to you here. Since I'm sharing this course also with some of my friends, even not close friends, but I probably will create a Google site for this course, and I will upload all of the materials on there. Then I don't need to share all the files one by one. So I may also provide you with that Google site, and you can also find all of the courses and materials there. But it's not created yet. I may create it on Friday or today, I don't know. But then I will let you know. Okay, if there is not any question, have a miss your email is no. In the first slide I said that. Even in these slides you can see in every page nknopa@trovub.be. This is my email address. Okay, thanks. Okay, everybody, have a nice day. Okay, seems that.
For the exercise that was given in the previous class, for the second question, I used this method to get the answer. But if I give it as 0 to 10, then I did not get 9 in my output.
Yeah, the problem is that 0 to 10. What are you doing? Yes, you cannot, because that's the problem. That's how I define this list. It depends based on the list, because if you start from 0, the first 0 to 10, you cannot put 0 to 10.
Oh, sorry, 0 to 8. Sorry.
Okay. Can you write what you wanted to do and what you didn't get?
Yes, one moment, please.
-1 to -10. This is correct. But you know, with your example is that it's, I mean, for you, it was optional to write this one because you are referring to the start and end of the list. And we said that since the default values for these parts are a start and the end of the list, and for this one, the default value is 1. So it's exactly similar to what I wrote here, but you wrote the default values by yourself. But I don't know, what did you wanted to do?
Okay, yeah, I understood now. But if I use the positive values, I did not get the same output. So I wanted to check regarding that. But
okay, let's try. Let's try. Online Python interpreter. This one might be better. Yeah. Okay, we have this one, and you want to print my list. You want to write 0, 0 till 10. And with what? With -2. So it will travel from this one, I guess. Run.
sorry, isn't it 0 to 8? Or if we want it in the reverse order, it's 8 to 0.
Like this?
Yeah,
The
zeroth
problem is that you are using positive values with negative things, and I guess because of that it's like that.
Ah, okay, so it doesn't work that way.
Yeah,
Okay.
but the problem is that if you, for example, wanted to do this one, it will give you, I guess, the even values.
Yes.
So that's why no, it gives. Yeah, it's correct.
If you write
Yeah, if I, for example, put here 10, because I, at first, before giving you this exercise, I put this one like this, and then you could not reach what I want. So you have to use loops or the other things.
okay.
But based on you should see the examples. It doesn't mean that every time that you need the odd numbers and even numbers, you can follow the same structure that I showed you. You may need to change these values a bit.
Okay. Thank you.
Okay, you're welcome. Okay, is there any other question? Yes, no?